Hello everyone and welcome to Sally and Bytes. This video includes CBSE Class 11 Computer Science Chapter 1, Computer System Organization Part 2. In this video, I will be discussing various aspects of computer system organization, such as Central Processing Unit, CPU, Output Unit, Memory, types of memory, primary memory, RAM, ROM, cache memory, secondary memory, and units of memory. So, let's dive in and get started. The basic component of a computer system includes the Central Processing Unit. The Central Processing Unit, CPU, is the primary component of a computer system that carries out the instructions of a computer program. It is often referred to as the brain of the computer because it performs the vast majority of the system's processing. The CPU interacts closely with primary storage or main memory, referring to it for both instructions and data. There are three basic components in the CPU register section: Arithmetic Logic Unit, ALU, Control Unit, CU, and the Memory Unit, MU. The first component of a CPU is the Arithmetic and Logic Unit, ALU. The arithmetic and logical unit of the CPU, that is Central Processing Unit, performs the mathematical calculations and logical operations that are required by a computer program. The ALU performs the arithmetic addition, subtraction, multiplication, division and logical and, or, not, XOR, operations, sent from the memory, and the result is returned to the memory. The result of logical operations is either true or false and helps the computer in decision-making. Have you heard about a microprocessor? What is a microprocessor? A microprocessor is a small-sized electronic component inside a computer that performs basic arithmetic and logical operations on data. The second component of a CPU is the control unit, CU. The CU controls the flow of data from input devices to memory and from memory to output devices. It controls all the hardware operations like input and output units, storage and processor. The control unit of the CPU is responsible for managing and coordinating the activities of the computer's various components, such as the memory, input-output devices, and other parts of the CPU. Next, we discuss about the registers. What is a register? Registers are high-speed temporary storage areas found in the CPU. Registers work as per the instructions given by the control unit, CU, storing instructions and data, immediately required for performing an operation. The CPU places the highest priority jobs or data inside registers for faster execution or processing. Registers can be of different sizes, 16-bit, 32-bit, 64-bit, and so on. Each register inside the CPU has a specific function like storing data, storing an instruction, storing address of a location in memory, etc. At this point, you have to note that the CU controls all the functions like input, output, storage, and process. It instructs ALU which operation is to be carried out. Have you heard about microcontroller? Microcontroller is a small computing device which has a CPU, a fixed amount of RAM, random access memory, ROM, read-only memory, and other peripherals embedded on a single chip. The third component of a CPU is the memory unit, MU. The memory unit of a CPU, Central Processing Unit, is a component that stores data and instructions that the processor needs to execute programs. It is where the processor temporarily stores data and instructions that it needs to access quickly while a program is running. Memory unit is an essential component for storing the programs and data executed by the CPU. Let's look at the types of memory. There are two types of memory. The first one is the primary memory, also known as main memory or internal memory, RAM and ROM, and the second one is the secondary memory, auxiliary memory, external memory, or backup memory or backing store. So, what is primary memory? The primary memory is directly accessed by the CPU. It stores the data and instructions that the processor needs to execute programs quickly. The CPU can read data from and write data to primary memory very quickly. What is secondary memory? The secondary memory is a type of non-volatile memory that stores data even when the power is turned off. It is used for bulk storage of programs, data, and other information. It has much larger capacity than the primary memory. It is used for permanent storage of data. It is used for long-term storage of data, such as documents, photos, and videos. Here you should also know about a memory cell. A memory cell is a device that stores a single symbol selected from a set of symbols. Let's discuss about the output unit. Generally, output devices are hardware components of a computer system that are used to display or present information processed by the computer. That is, the output. Some common output devices. Monitor or Visual Display Unit, VDU. A monitor or visual display unit, VDU, is an output device that displays visual information on a computer screen. It is the primary way that users interact with a computer and view the output of programs that are running. A monitor typically consists of a flat screen or CRT, cathode ray tube, that displays images and text in various colors and resolutions. It is connected to the computer's graphics card or video adapter, which is responsible for sending signals to the monitor to display the images. Monitors come in different sizes, resolutions, and refresh rates. What do you mean by resolution? The resolution refers to the number of pixels on the screen, and what is meant by refresh rate? Refresh rate is the number of times per second that the screen is redrawn. A higher resolution and refresh rate generally result in a clearer and smoother display. Here we are going to learn about the different types of monitors. The first one is LCD. Liquid crystal display. It is smaller and lighter in weight as compared to a CRT monitor and hence, ideal for use in laptops, palmtops, and other portable devices. The next one is LED. Light-emitting diode. It is lightweight flat panel display and uses light-emitting diodes to create pixels on the screen. LED monitors use less power as compared to CRTs and LCDs and are considered environment-friendly. The next one is OLED. Organic light-emitting diode. This technology is more advanced than LED. It uses an organic substance which glows when an electric current is passed. This revolutionary material reduces the thickness and weight of the TV, creating an ultra-thin, sleek form, superior color, reproduction, and individual pixels that switch off for true blacks. Printer. A printer is an output device that prints text and images on paper or other types of media. The output of the printer taken on paper is known as hard copy. Printer is used to produce hard copies of electronic documents or files. Printers vary in size, speed, cost, and quality of printing. Printers can be classified into two broad categories: impact printers and non-impact printers. The main difference between an impact and a non-impact printer is the way they create the printed image. The first difference is impact printer uses a physical impact, such as striking a ribbon against paper, to create the printed image. Whereas non-impact printers does not use a physical impact to create the printed image. Instead, they use methods such as spraying ink or toner onto paper or using heat to transfer the ink onto paper. The second difference is that impact printer typically make a noise when in operation and are slower than non-impact printers. But non-impact printers are generally faster and quieter than impact printers. The third difference is that the impact printers are able to create multiple copies of a document by using carbon paper. But non-impact printers can produce higher quality images. Example of impact printers are dot matrix printers and line printers. Example of non-impact printers are inkjet printers, laser printers, and thermal printers. Let's discuss about the types of printers which are the output devices. Inkjet printers. These printers use ink cartridges to produce high-quality color and black and white prints. They are generally less expensive than other types of printers and are suitable for home or small office use. The next output device is the laser printer. These printers use toner cartridges to produce high-quality black and white prints. They are generally faster and more expensive than inkjet printers and are suitable for medium to large office use. The next output device is the thermal printer. These printers use heat to transfer ink or dye onto paper, labels, or other media. They are commonly used in retail, shipping, and manufacturing industries for printing labels and receipts. The next output device is the dot matrix printer. These printers use a print head that strikes a ribbon to produce text and images on paper. They are generally slower and produce lower quality prints than other types of printers, but are still commonly used in certain industries, such as banking and healthcare. The next output device is the 3D printer. These printers use a process called additive manufacturing to create three-dimensional objects layer by layer. They are used in various industries, including manufacturing, healthcare, and education. The next output device is the speaker. A speaker is an output device that produces sound from the computer. It can be used for listening to music, watching videos, or hearing system alerts and notifications. The next output device is the headphone. Headphones are a type of output device that can be used to listen to audio output from the computer. They are often used in situations where it is not appropriate to use speakers, such as in public places or shared spaces. The next output device is projector. A projector is an output device that displays an image or video on a larger screen or surface. It is often used in presentations or for watching movies in a home theater. The next output device is the plotter. A plotter is an output device used for creating large-scale drawings and designs. It can draw precise lines and curves on paper or other materials. The next output device is the Braille printer. A Braille printer is an output device that prints text in Braille for visually impaired users. It converts text from the computer into Braille characters that can be read by touch. The next output device is the digital signage. Digital signage is an output device used for displaying information in public spaces such as airports, train stations, and shopping malls. It typically consists of a large digital display that shows advertisements, news, or other information. I hope you have a clear understanding of the output devices. Now let's discuss about the memory. Memory in a computer refers to the electronic components that temporarily store data and instructions for processing by the Central Processing Unit, CPU. There are two types of memory in a computer system. Primary memory, also known as main memory or internal memory. Secondary memory, also known as auxiliary memory, external memory, or backup memory. So, what do you mean by primary memory? Primary memory is very important as the data stored in it can be directly accessed by the CPU. It is also known as main memory or internal memory. It is used to temporarily store data and instructions that the CPU needs to access quickly. The two main types of primary memory are random access memory, RAM, and read-only memory, ROM. What is a RAM? RAM is random access memory. It is a read or write memory as it is possible to both read from and write to a location within RAM. It is a volatile memory, meaning that it loses its contents when power is turned off or interrupted. It is used to store data and instructions that the CPU is actively using or processing. The RAM, random access memory, chips in a computer can be categorized into two main types: dynamic RAM, DRAM, and static RAM, SRAM. DRAM is the most common type of RAM used in modern computers. It stores data in a series of capacitors, which must be constantly refreshed to maintain their contents. DRAM is cheaper and slower than the other type of RAM, called SRAM. It is used in main memory. SRAM is faster and more expensive than DRAM. It stores data in a series of flip-flops, which retain their contents as long as power is supplied. SRAM is used primarily for cache memory, which is a type of high-speed memory that stores frequently used data for faster access by the CPU. Both DRAM and SRAM are volatile memory, meaning that their contents are lost when power is turned off or interrupted. RAM is used to temporarily store data and instructions that the CPU needs to access quickly. The amount and type of RAM in a computer can affect its speed, multitasking capabilities, and overall performance. Note: RAM provides faster access than secondary memory with less memory access time. Here you should know about the memory access time. Memory access time is the amount of time taken to retrieve data required from memory, from start of access until the data becomes available. Now we can discuss about ROM. Read-only memory. The data and instructions are placed in the ROM at the time of its manufacturing and can't be changed thereafter. It is permanent and non-volatile memory, meaning that it retains its contents even when power is turned off or interrupted. ROM is slower than RAM. It is used to store important instructions that the computer needs to access every time it starts up, such as the BIOS, Basic Input-Output System. That is, to check the basic hardware components such as booting, procedures to load operating system, and frequently needed functions. There are several types of ROM. They are: PROM, programmable read-only memory. This type of ROM is programmed by the user, using a special device called a programmer. Once programmed, the contents of PROM cannot be changed. EPROM, erasable programmable read-only memory. This type of ROM can be programmed by the user and erased by exposing it to ultraviolet light. EPROM chips are often used in older computers and other electronic devices. EPROM, electrically erasable programmable read-only memory. This is a type of ROM that can be programmed and erased electronically, without the need for ultraviolet light. EPROM is used in many modern electronic devices, such as smartphones and digital cameras. Flash memory. Flash memory is a type of EPROM that can be erased and reprogrammed in blocks instead of 1 byte at a time. It is used in many types of portable electronic devices, such as USB drives, memory cards, and solid-state drives, SSDs. Mask ROM. This is a type of ROM that is pre-programmed by the manufacturer and cannot be changed by the user. Mask ROM is often used in specialized applications, such as in embedded systems and game consoles. Now we can have a glance on the differences between RAM and ROM. RAM is possible to both read data from memory and write data into memory. But only reading of data from memory is possible in ROM. RAM is volatile. If the power supply is interrupted, then the data is lost. ROM is non-volatile. The data is maintained even if the power supply is lost. RAM is mainly of two types: dynamic RAM and static RAM, cache memory. ROM is mainly of the following types: programmable ROM, erasable PROM, EPROM, and electrically erasable PROM, EPROM. RAM is used for temporary data storage as it is volatile. But ROM is used for permanent data storage as it is non-volatile. Hope you can understand better now. Next, we can have a glance on the difference between volatile and non-volatile memory. Volatile memory requires a constant supply of power to retain its data, but non-volatile memory retains its data even when the power is turned off. Volatile memory is faster than non-volatile memory. It is designed to be used as temporary working memory and is optimized for fast read and write operations. But non-volatile memory is slower than volatile memory. Volatile memory is used for temporary storage and typically has a smaller capacity. But non-volatile memory has a higher storage capacity than volatile memory. It is designed for long-term storage and can store large amounts of data. Volatile memory is less expensive than non-volatile memory. But non-volatile memory is generally more expensive than volatile memory. Example of volatile memory is random access memory, RAM. Example of non-volatile memory is read-only memory, ROM, flash memory, and hard disk drives, HDDs. Let's learn about the cache memory. Cache memory, also called CPU memory, is a type of high-speed memory that stores frequently used data and instructions. It is located closer to the CPU than other types of memory, which allows the CPU to access the cache data more quickly. When the CPU needs to access data or instructions, it first checks the cache memory to see if the data is already stored there. If the data is present in the cache, the CPU can retrieve it quickly, without having to access slower types of memory. Cache memory can be built into the processor or located on a separate chip near the processor. The size and type of cache memory used in a computer can have a significant impact on its performance, with larger and faster caches typically providing better performance. The second type of memory is the secondary memory. Secondary memory is also called auxiliary memory, external memory, or backup memory. It is used for bulk storage of programs, data, and other information. It has much larger capacity than the primary memory. The secondary memory is non-volatile and is used for permanent storage of data. Here we learn about the secondary memory devices. Hard disk. A hard disk drive, HDD, is a data storage device that uses magnetic storage to store and retrieve digital information. It consists of one or more rigid rotating disks, also called platters, coated with magnetic material and an array of read or write heads, to access and modify the data stored on the disks. The platters spin at high speeds, typically ranging from 5,400 to 15,000 revolutions per minute, RPM, and the read or write heads move across the surface of the disks to access the data. The data is stored in concentric circles, called tracks, on the disk surfaces. Track. Each platter is divided into concentric rings called tracks. There are thousands of tracks on each platter. A track is divided into segments of sectors, which is the basic unit of storage. Sector. Each track is divided into sectors that actually store the data. A sector, as a rule, holds 512 bytes of data. Cylinder. A cylinder consists of a set of tracks described by all the heads, on separate platters, at a single seek position. Each cylinder is equidistant from the center of the disk. Hard disks are commonly used in desktop and laptop computers, servers, and other electronic devices that require high-capacity, non-volatile storage. They have large storage capacities, ranging from a few gigabytes to several terabytes, and are relatively inexpensive compared to other types of storage devices like solid-state drives, SSDs. However, hard disks are slower and more susceptible to physical damage than SSDs. The next secondary memory device is the Blu-ray disc, BD. The name Blu-ray disc is derived from the blue-violet laser beam that is used to read from and write to this type of disc. With their high storage capacity, Blu-ray discs can store higher resolution video and audio, as well as photos, data, and other digital content. A Blu-ray disc can store 25 gigabytes of data, over 5 times the sizes of a DVD. The next secondary memory device is the compact disc, CD. Compact disc, CD, are known as optical storage devices. A compact disc can store approximately 700 megabytes of data. A laser beam is used for storing data on the disc. Compact discs can be of two types, CDR and CDRW. CDR is called recordable CD. Data once recorded on CDR cannot be erased. CDRW is called rewritable CD. Data stored on the CDRW can be erased and new data can be stored in its place. The next secondary memory device is the magnetic tape. Magnetic coatings are stored as data on a thin tape. Data read or write speed is slower because of sequential access. Magnetic tapes are convenient, secure, and affordable. Companies across the world still rely on this technology to keep their records safe. The next secondary memory device is the DVD. A DVD is also an optical storage device like the CD. Laser beam is used to store and read the data. A DVD can store much more data than a CD. A single-sided DVD can store about 4.7 gigabytes of data. DVDs which store data on both sides can hold over 9 gigabytes of data. The next secondary memory device is the USB pen drive. A pen drive is a storage device that is small in size and can be carried easily. It is a USB device that can be used to quickly transfer audio, video, and data files from the hard drive of one computer to another. A pen drive uses flash memory. Flash memory is a technology that allows data to be electrically stored, erased, and reprogrammed. The next secondary memory device is the memory card. A memory card is small in size and can store data in digital format. It is used in various electronic devices like mobile phones, digital cameras, MP3 players, and many other portable devices. Hope you had a better understanding about memory, types of memory and memory devices. Now let's learn about the units of memory. Bit, short for binary digit, the smallest unit of memory, representing a single 0 or 1. Byte, a group of 8 bits, used to represent a single character, such as a letter, number, or symbol. Kilobyte, KB, 1024 bytes. Megabyte, MB, 1024 kilobytes. Gigabyte, GB, 1024 megabytes. Terabyte, TB, 1024 gigabytes. Petabyte, PB, 1024 terabytes. Exabyte, AB, 1024 petabytes. Zettabyte, ZB, 1024 exabytes. Yottabyte, YB, 1024 zettabytes. Brontobyte, 1024 yottabytes. Thanks for watching. Watch the upcoming videos, Computer System Organization, Part 3, which includes software concepts, types of software, system software, application software, utility software, programming tools. Kindly check the link in the description box below.